Welcome to The Explainer. Today, we're jumping into the world of exponents. Think of them as mathematical superpowers that let us wrangle gigantic numbers and super tiny fractions without breaking a sweat. So, let's unlock these secrets together. All right, let's kick things off with this problem here. At first glance, it's just kind of a jumble of letters and numbers. I mean, we could write it all out the long way, but man, is there a better way?
So think about what this actually means. A squared is really just a team of two a's, right? And a cubed is a team of three. When they join forces, all we have to do is count them up. So 2 plus 3, that gives us a super team of 5 a's. In other words, a to the 5th hour. Simple enough.
Okay, but hold on. What about this beast of a problem? Are we seriously supposed to write out n 11 times and then write it out another 35 times just to count them? No way. I'm not doing that. You're not doing that. There has to be a shortcut. And that right there, that feeling of there's gotta be a better way, is exactly why mathematicians developed what I like to call superpowers. And today, we're gonna learn the rules that unlock them. All right, let's get into these superpowers. We're gonna cover 3 core rules, and trust me, they're not here to trick you. They're designed to make your life a whole lot easier when you're dealing with this stuff. Okay, our first superpower is the multiplication rule. Now, the most important thing to remember here, the key, is that this only works when the bases are the same. You know, the big number or letter on the bottom. As long as they match, all you do is add the exponents. Seriously, that's it. And here's the why behind it. It's not some kind of weird math magic. We're literally just grouping the same things together. You've got a group of 2 a's, you add a group of 3 a's, and what do you have? A total of 5 a's. It's all just about combining teams. And boom, just like that, our so-called impossible problem is suddenly super simple. Remember that thing we didn't want to write out? Now it's just 11 plus 35. It's done, solved in a flash. That is so much better than writing out 46 times, right? So we know how to combine powers with multiplication. What about when they face off in division? Let's check out the shortcut for that. And what's really cool is that the logic is super consistent. I mean, if multiplication means we add the exponents, it just makes sense that for its opposite, division, we're gonna subtract them. It's a really nice, clean pattern. So why does this work? Well, just imagine you write it all out. You've got 5 a's on top and 2 on the bottom. For every a in the denominator, you can cancel out 1 from the numerator. So these 2 cancel these 2, and what are we left with? Just 3 a's on top. It's all about cancellation. And check this out. A problem that looks like a total monster, 2 to the 16th power, who wants to calculate that? But with our rule, it just becomes a simple subtraction problem. 16 minus 12 is 4, and 2 to the 4th power, that's just 16. Done. So much easier. Okay, time for our third and final rule. This one is all about what happens when you give a power even more power. So here's the rule. When you're raising a power to another power, you multiply the exponents. And the big giveaway, the thing you gotta look for, is the parentheses. When you see a power inside those parentheses with another one chilling on the outside, that's your cue. It's time to multiply. And here's the really cool part. See how this all connects? Taking a squared to the 3rd power is just another way of writing a squared times a squared times a squared. And from our first rule, we know we just add the exponents. 2 plus 2 plus 2 is 6. So really, multiplication is just a fast way to do repeated addition. It all comes full circle. Okay, so now you have these 3 superpowers. But with great power comes, well, a few common traps you need to avoid. So let's talk about mastering these rules so you don't make the classic mistakes. This is maybe the most common trap of all, mixing up the multiplication rule with the power of a power rule. Your brain sees those 2 little numbers, the 3 and the 5, and it just wants to add them to get 8, but you have to resist. Look for the parentheses. When you see a power raised to a power like this, you have to multiply. So it's 3 times 5, which is 15. Here's another classic mistake, forgetting about the number in front, the coefficient. It's so easy to just apply that power of 4 to the x and call it a day. But that power, that 4 on the outside, applies to everything inside the parentheses. Think of it like a coat that has to cover everyone in the group. So the 2 gets raised to the 4th power too. Don't leave it out in the cold. And I just love this thought right here. Making a mistake isn't the scary part. We all do it. The scary part is not learning from it.
The whole goal isn't to be perfect. It's to learn from those errors and get stronger every time. That's what problem solving is all about.
So let's zoom out for a second. Why are we even learning this? Is this just for math tests? Absolutely not. Turns out, exponents are pretty much everywhere.
I mean, think about it. Astronomers use them to measure the insane distances between stars and planets. In computing, all our memory storage, kilobytes, megabytes, gigabytes, it's all based on powers of 2. If you've ever put money in a savings account, that's compound interest, which is all about exponents. Scientists use it to model how cells grow. Physicists use it for, well, basically everything. Exponents are the language we use to talk about the incredibly big and the incredibly small.
So that leaves us with a question to chew on. Exponents describe anything that grows by multiplying. What else in our world grows like that? Exponentially. Think about how a video goes viral or how populations grow. This concept is absolutely all around us. And that's our explainer for today. I hope you now feel a little more empowered by the rules of exponents.